Okay. So you may have, I may go over some stuff that has already been gone over, but I don't suppose it'll hurt. And some of the stuff would have been in the videos you watched as well. But just a quick thing about profiling, or the purpose of profiling. And the reason that we profile FHIR resources is because FHIR resources, most of the data elements are optional. The terminology isn't mandated in many cases. Also, the 80-20 rule means that some concepts don't exist and need to be represented by extensions. So basically, for your use case, you probably want some extra constraining, and you may also want to add some extra information to your resource that isn't already there. So basically, you can make elements required or limit the number allowed, bind terminology like a value set or a code system, or you can actually fix a code. You can also create or reuse extensions to represent whatever concepts you want. So a profile always starts with a base, either a base FHIR resource, and I don't have the rest of that sentence, but either a base FHIR resource or a profile that already exists. So a really common case is to use a US core profile as the base for your new profile. So, you know, that you could start with an observation, a condition, medication. Oh, I do have my second line right there. Or an existing profile like US core patient or a US core condition. And to describe a particular use case, the profile lays constraints over the top of the base resource or profile to either constrain it further or to extend it with extensions. So in the profile, you have a snapshot and a differential. And when I say profile, by the way, that's synonymous with structure definition here, really. A profile snapshot includes the details of all the data elements in both the base resource and the profile. And the profile differential includes only the details of things that have changed in the profile. And I think that's what you were talking about with sparse differential. Though I'm not sure, what's a non-sparse differential? The snapshot?
A non-sparse differential will be still the different elements, but it will give all of the parent elements all the way up. So a sparse literally only says if you just change patient.id code, then it will only put patient ID code in the differential. However, if for full differential, we'll put patient and put ID and code.
Right, okay. I didn't know that either. So profiling steps. So the way that you create a profile is you create a structure definition resource, which is the profile. And we just did that. We basically just copied an XML from another IG. And I do a lot of copying and pasting because really you don't want to start by reinventing the wheel. So if you find something that looks similar to what you want and you're using XML, then that's a good way to do it. Then you populate the needed metadata like the name, the URL, the description, and Dragon showed those in the XML. Then you constrain the data elements you want for the particular use case. So you know, you might be saying you have to have a code here, you only want one of this code or multiple of this code. You can create an example instance that conforms to the profile, and this is really super helpful in validating that your profile does what you want it to do. And then you can use the profile by adding it, say adding it to an IG.
And there's one thing I want to add, it's kind of important. You can only further constrain a resource or profile. You cannot relax it, okay? So if it is, you know, 1.1 as a cardinality, you cannot make it 0.1, okay? You can make something at 0.1 or 0.1, 1.1, but you can't make anything less constrained than it is already.
So the types of constraints, you can change the cardinality, you can add terminology binding, you can do slicing, you can add must support, you can create and add extensions. There's probably more, but these are the main ones that we deal with. So this is changing cardinality. That's the minimum maximum for an element. 1 to 1 is exactly 1, 0 to many, 0 or more, at least 1. Most FHIR elements in the base resources are optional. So constraining, and what David just said, constraining cardinality you can change to be more restrictive. So you can say make optional elements required, multiple elements to only 1, but you can never make them less restrictive. So you can't make required items optional, and you can't make singular items repeating. So this, I hope you can see that. And this is kind of to help put it all together. So this is the base questionnaire resource, and it is 0 to many. The base questionnaire resource has a subject type of 0 to many. And then in your structure definition, you're saying, oh, thank you. In your structure definition, you're saying the element is questionnaire.subject type, the path is questionnaire.subject type. There's some definitional stuff in there. And then you've got a minimum value and a maximum value. So we're changing that from 0 to many to 1 to 1. So you have to have exactly 1. And then when this all gets magicked by the IG publisher, the resulting profile then shows up the differential. The subject type has been changed to 1 ... 1. I'm going to go back and forth. So. Oh, unless you want to say something. And then we have terminology binding. So these are the codes that are allowed for a coded element. The bindings are, you can have a fixed binding, so this is like a single code and system, and so everything not specified is prohibited. For example, if you have a codable concept and you set the display, you set the code and the code system, you can't then go and add a display, or the implementer can't go and add a display. This is slightly different to pattern. Pattern is where if you have a single code and system, everything not specified is allowed. So if you set, you have to have the code as something and you have to have the code system as something else, you can then put in a display of whatever you want. And you can also add extensions here, which I think ends up being prohibited if you use a fixed. You can also bind to a value set, and you have several different strengths of binding for that. So you have required, extensible, preferred, or example. And I thought I had a slide somewhere that explained that. Binding strengths. We'll just go to here. So the binding strengths are required. You have to use a value from that value set. You can't use any other values. Extensible. If the code does exist in the value set, you have to use it. Otherwise, you can use another value. This doesn't mean that you can extend the value set. It just means you can use other codes in that code or that binding. Preferred, that's just a recommended but not required value set. An example, it's not expected that you're going to use these values. It's just an example value set. So here's an example of the terminology fixing a code. So we have the subject type. Right now it has no terminology specified. And then in the structure definition, we've said the fixed code has a value of group. And this is just a code, so it doesn't have a code system or anything. And then this is the magicked one after the IG publisher. And you can see it says fixed value is group. And then the pattern is similar to this one. I didn't put a slide in it, but it would look similar, except it says pattern, and it lists what you can have. Then we have value sets, and the same thing here. We have the code, as it was before, but then in this case, we have, this is a coding, and we have a binding. The strength is required. It's got a description, and it's got the value set that you have to use there. You can't use any other codes other than that. And then you can see here the resulting profile. We have the binding, tells you it's actually got the name of the value set, and it says that it's required right there. And, oh, I can't see anything, by the way, so it doesn't matter. I'm just can't. So fixed means that if you set anything, so if you have a codable concept which has a bunch of different elements, like code and display and code system, if you only set 2 of those, that's it. That's all you can have. Nobody can ever, an implementer couldn't go and add a display in there. And also, Lloyd, I think you said something about you can't extend it either. You can't put an extension on there if you need to, or if you wanted to, with the fixed.
As long as it contains stuff in the pattern, it can contain anything else.
So if you say that the code is XXX, it always has to be that code. And if you say the code system is this code system, it always has to be that code system. But if you haven't stated anything for display, then the implementer can put whatever they want in display. I can't hear you.
Did you have it on the previous slide? Because I couldn't read the pattern examples.
It is confusing.
Do you have a use case for that as to like the reason why you might, it might be easier to put some context around it if I had a use case for why you would use pattern.
Well, my instinct is always to use fix, but
Well, mine would be too.
and honestly, but I don't because I've been told not to use it by Lloyd years ago. So maybe
And Lloyd can tell you why. So the reason that you don't generally want fixed, the reason that you want pattern and not fixed is you generally don't want to keep people from saying other stuff. So if I want to make sure that the LOINC code is going to be this particular code and that it's going to be from LOINC, I don't want to prevent them from sending display names. I don't want them to prevent them from sending a version. I don't want to prevent them from sending also a SNOMED code and other things. What pattern does is it says, so long as they've got a coding in that list where the system says LOINC and the code says this, then doesn't matter if they've got display names, doesn't matter what they are, doesn't matter if they've got versions, doesn't matter what they are, doesn't matter if they've got 15 extensions. None of that stuff matters. They've got the key stuff that I need, so I'm good. You use fixed in those situations where you really need to say, this needs to be exactly this, because my code is going to do a binary check against it. If it doesn't exactly match, it's going to blow up. And there are some use cases where you really need to be that tight, but there aren't very many. The other place where we often use fixed, because the chances of there being other stuff around is slim, is you might say the sequence number of this needs to be 1. That prevents you from sending an extension on the sequence number, but realistically, not likely that anybody's ever going to do that. And so the convenience of just being able to say this is a fixed value, as opposed to trying to get a developer to understand, so what does it mean to say that the pattern of this is a value of 1, is just not worth it. But so typically we only use fixed for simple values, things like code or integers, and we use pattern for all of the complex things, is the sort of common practice.
You had a question first. All right.
And just a little bit of an example, you asked for use cases. In a clinical setting, if you have a codable concept, a lot of times you want to fix that to a specific code saying that it has to be this code, but usually in the field they want to throw other codes in there as well. And if it's fixed, you wouldn't be able to do that. But if it's a pattern, you could locally say, yeah, I'm going to do the code that I have to do for this breast exam, but I'm also going to throw in these other codes because I'm doing something special. So.
Thank you. I understand that use case. I still scratch my head a little bit and ask myself from a semantic consistency perspective. I'm not sure how that works, but that aside, so is extensibility then, is that sort of the pattern version applied to value sets? Is it sort of allowing for a similar?
I suppose it is really, yeah.
Yeah.
Extensible means you can add to the value set.
Yeah, but you have to, no, it doesn't mean you can add to the value set. It means you can, so this is what I understand. It means if the concept lives in that value set, you have to use that code. If the concept does not live in that value set, then you're free to use your own code or another code. But it doesn't mean you can add to the value set because it's not actually talking about the value set, it's talking about the binding.
Well,
It is, I agree with that. It's kind of like pattern.
yeah, I mean, what you're really doing is saying that the value set here contains these codes, and you can define a local value set that includes codes from the base value set plus other stuff, but the other stuff can't cover anything that's in the base value set. And it's not the exact same concept, but covered by is a little bit fuzzier. So have you seen the color example in terms of what extensible means? Okay, so if your value set is red and green and blue, and I want to send orange, orange is totally fine because it's not covered by red or green or blue. If I want to send emerald green, I can send that as well as green, but I have to send the green code because emerald green is a type of green and therefore it's a concept that is covered by the value set. So I don't get to say, well, it doesn't cover the specific kind of green that I want, and therefore I don't have to use it. If it covers green at all, you have to use the code that's there, but you can send others so long as it's a codable concept, because you can have multiple codings.
That's pretty subjective. Yeah.
Yeah, it is not computable at all.
Right.
You cannot do a
computable,
computable
except-
test to verify whether you're compliant or not. It has to have a human being look at it and say, is this covered by the value set or not?
It's our favorite thing, Lisa. Gray.
Sarah, can you go to the previous slide? I want to see how you specify fixed pattern.
To
You have an example that shows.
Oh,
how-
fixed. So this is just a code, subject type. So it's probably, this is a place where you probably would do always, you'd never put a pattern in there.
So that means if that code did come from Loin for some reason, you could not put code system plus Loin because it's a fixed pattern,
Well, this is a fixed code.
fixed code. But
There's no system.
There's no, your constraint doesn't allow us to include a code system.
Correct.
So even if you wanted to, you couldn't.
Right, but I think that's but this is a code
type doesn't allow it.
data type that doesn't allow, it only allows a code. It's like a coded simple in CDA.
It's a string.
Yeah. And I think for this one, subject type, it has the base structure questionnaire has a value set that you have to use anyway. So we're just fixing it to one of those values. Perfectly clear on everything?
Question. In the documentation that we are producing, will there be an index of if you want to do this, then you can find it on this constraint? So an example of these things. So if you want to constrain a terminology, if you want to add a logical model, if you want to have a terminology resource, I'm just asking, will there be documentation for that, or should there be documentation for that? Should we create some guidance on these things? I expect much of our users will be asking these questions again and again and again. So if we have any base documentation, it's not what it means in FHIR terms, but from the use case, or if you want to constrain a terminology, here's the two ways of doing it, and here's an example of how you do it.
Well, I think a lot of that's actually in the FHIR base documentation, like the FHIR documentation itself.
Terminology, but HTML has all of the.
The terminology chapter of the FHIR.
It is. It absolutely is scattered.
So and if our users are going to say, I want to start a new implementation guide, where they start? They start by going through the whole thing, and this means proficiency will come quite later, I think. I'm just thinking out of ideas to make it easier for.
It's always a good idea that if there is a difficult concept in your IG, to put some prose around it, to write up a description, to put something in the actual documentation around it, say this is why we did this, or this is, you may not want to do exactly this is how you do it, because if you're working with FHIR, you should know how to do an extensible set. But it's a good idea if you need to explain why, or what the use case is behind it, or the reason behind it, yeah, put it in the prose.
More for the examples of the color example. Okay, that's clear. And then we just put, here's an example of how you change a color. That's.
Yeah, that might work, yeah.
Okay. So now I'm going to talk about slicing. Slicing is taking an element that might occur more than once, for example, in a list, and splitting that list into a series of sublists, each with different restrictions. The classic example, and this is the example that is in the FHIR documentation under profiling, is a blood pressure observation where there are two components, systolic and diastolic. So we say that each component is a slice, and each slice has a different fixed LOINC code to differentiate it from any other component. One for systolic and one for diastolic. And a discriminator is the thing that identifies the slice. So the discriminator identifies a slice, and the system checks to distinguish between multiple slices. So there are several discriminator types. Value, which is checking the value of, say, a code. Exists, whether something exists or not, that's just Boolean, binary. A pattern, a type, and a profile. So the blood pressure example would be value. So the system would check the value of the element for the correct LOINC code, or for, discriminate between two LOINC codes. So here we have the same setup as before. So we have the base, we've got a questionnaire, we've got a code, it's of type coding, and you can have multiple. So the structure definition sets this all up. So we're in the structure definition, and we're going to be slicing on code. So we have element, questionnaire code, and then we have the discriminator. So we're saying ignore the second discriminator, because in this one I did a really complicated thing and did two different kinds, but we'll just talk about the value one at the top here. But you can have multiple. You can slice multiple ways. So the discriminator is type of value, and the path value is code. So we're actually going questionnaire code dot code. So we got questionnaire code dot code somewhere down here. I can't actually see them too far away. Right here. Questionnaire code dot code. So we're setting up the slicing up there on that questionnaire.code element. Then down here, we set up some slices. So this particular slice code, what's it called? Slice HAI. It has a fixed code of whatever that LOINC code is. So we have set up the slicing. We're naming the slice. And then we have another slice here, and this is the binding. This is like just the pattern. We won't get too much into that because it's a bit more confusing, but the value one is the one that we're looking at. So any questions so far? Because this is confusing, by the way.
So would another example of when you would do a slice, let's say you have a patient identifier and you want to explicitly say social security number and a driver's license required. Is that a slice?
Yep.
On identifier or whatever the right, I don't know what the name
Yep.
of this is.
Yep.
Okay, thank you.
Can you just talk one more time about the relationship between the slice and the discriminator? I think I understand the concept of slice. The discriminator.
So the discriminator is what differentiates between two things that are pretty much the same. So if you have two codes, you need to say that this first code is a slice and it's going to be this thing, and the second code is a slice and it's going to be this thing. And I feel like somebody else was going to explain just now. No? Oh, you were walking over to give him the thing. Okay.
Is there, I've had a little bit of difficulty seeing the profile resolve discriminator. I can see examples of other kinds of discriminators. Can you point to a good example of that one?
I feel like I have one in...
There's a good example in US Core in the practitioner, because they want to have the NPI, the National Practitioner Index identifier. There we go.
But no, that's not a profile, though, is it? That's not a resolve one? That's value, isn't it?
Yeah, it's sliced on value.
So he's talking about slicing on a profile. I just did it recently. I'll think about it and I'll get back to you on where one of those is, because I just did one the other day. Yeah, so you can say that, well, in composition, so CCM FHIR is a perfect example, yeah. So you can slice on, so your sections are sliced on
Code, usually.
No, it's not the sections, it's when you get down to the entries.
Right.
So
Yeah.
you got sections, and then they've got a bunch of entries, so you're pointing to US Core allergy or something, and then in whatever, in the sections, you can have several different types of entries in there, and that's where you would do it. So CCM FHIR is a good one for that.
You want to be careful about slicing by profile because it's really expensive. Essentially, what you're going to do is you're going to validate the reference or the thing that's being pointed to against all of the possible profiles and see if it's valid against only one, then you're good. If it's valid against more than one, then you got a problem. If it's valid against none of them, then you got a problem. But validating against a profile can be a very expensive thing.
So what do you mean by expensive?
It takes lots of time.
Okay. Yeah.
So it's going to significantly increase the amount of time that it takes to validate your instances.
Right. But I think sometimes you just don't have a choice. Like in cases like that where you're, maybe you could dive down in there and get the LOINC code on or the code on allergy or something. But for a problem, you wouldn't be able to because I think you have different codes and different values. So, yeah.
Yeah, if you can point to a specific element,
Right.
that even if it's nested in
Right.
something that's referenced, that's going to be more efficient than validating against the entire profile.
Right.
Because that's going to check every single value set, every single element, every single cardinality in the entire thing.
Yeah, I'm just thinking in some cases there won't be because you'll have a value set for both code and value and things like that. So, but yeah.
The slide up is the different ways of slicing again.
Sure. So that one there, the third one down, the pattern, that's the one. That's this one that I have here, the second one here, and we've got. Is it a pattern? Did I set it up as a pattern? I'm totally confused now. Yeah, it's a pattern here, and the pattern is the value set. And honestly, it took me 4 hours to figure out how to do this, by the way, the other day.
Yeah.
With the two
Don't feel
discriminators.
bad if you don't understand slicing at this point. Lots of people don't, and we've been doing it a while.
Right. So it took me ages to figure out that needed to be a pattern, and it also has there's specific things that needs to happen here with it. If you're slicing on a pattern, if you're slicing on a value set, the binding has to be required, and it's a pattern. And then what was the other ones? There's type. I can't think off the top of my head what a type. Can anybody think of an example for a type slice?
You have a value that could be an integer, a positive int, or an unsigned int.
Right. Right.
Yeah, we implicitly slice on type all the time whenever you've got something like observation.value, where multiple
Right.
types are allowed. When you are saying, I want to set what the constraints are if I have a value codable concept, and I want to set different constraints if I have a value attachment, that is type slicing.
Do you have to specify what type of discriminator is when you're, let's say, filling it out? Does it have to know? I mean,
You can-
Is this a coded list of values of this pattern type of profile?
You can leave it out, but then the IG publisher will complain. But it's not mandatory to say what it is. Yes.
And if you classify it wrong, does it complain more?
Well, if you classify it wrong and then you try to validate an instance against it, it'll say, well, that's the wrong. This doesn't match any discriminators.
Okay. I have a lot of problems with that.
Slicing's hard. It is.
Yeah.
Right.
Yeah. So it is possible to have just a discriminator description instead of a computable discriminator. So
That's the thing. You have to have a description if you don't have a...
you have to have a description
Right.
if you don't have it computable. If it's not computable, then it's not computable. So you cannot validate with a computer. It has to be validated by a human being. So you could say things like, if it's coded in XML, then it looks like this, and if it's coded in JSON, and you can do all sorts of really weird things, but generally speaking, really weird things don't help when you're trying to get interoperable happening. So if you think that you need a non-computable discriminator, ask on chat.fhir.org, and we will do our best to help you not have that be the solution.
Modify the XML directly, right? So you
No.
it's not
No. You can do it in
you can do
Trifolium FHIR and Forge.
but
Yeah.
not in the spreadsheet way.
Oh, no, you can do it in the spreadsheet, right, Lloyd? Slicing, you can do it in spreadsheet. Yeah. Yeah.
Oh, how would you do that? I mean,
I don't know how to do it in the spreadsheet.
There's an example. I mean, so
So yeah, it is so important, and you use it all over the place. So all the tools, definitely. Okay, any more questions about slicing? I think that's that was it for slicing. So I don't know if we're gonna. Did we have that in any exercises? No, advanced.
Yeah, at this point, well, if you want to learn about slicing, please do. We won't be teaching it here.
That's not true.
Well, we just did teach it. They should be able to do it
We
now.
can run late.
We can run till midnight.
You ought to be able to say, in US core, if you look at the blah, blah, blah profile, you can see examples.
Yeah, and I am going. That's my last thing. Is I'm going to take us through a U.S. core profile. So then another cardinality is must support, and this is just that implementers have to provide support for the element in some meaningful way. So they have to support the element. They have to be able to deal with it. They have to be able to receive it or send it or whatever. And this is often used for items that we want to require, but for which data sometimes doesn't exist, for like allergies. And this is a place I struggle too, coming from CDA, is we're so often putting it in, this is a required element, and then just use a null flavor if you don't have the data. And I think maybe must support is more like V2, where you're saying that it's required, RE, required, required if it exists or whatever.
And the best example for must support is US Core, where they have several paragraphs defining what must support means.
Oh, do they?
Yes.
I need to read that.
You can define what must support means in your IG by going into the pros and saying, hey, if you receive it, this, you have to do that. If you have to be able to read it or extract it or store it or something. You can say what must support means.
I heard that was changing, that everybody doesn't get to define must support separately.
Well, everything's possible.
Everybody has to define must support.
Rumors.
Yeah.
Who's your from, Lisa? Because it sounds like
Yeah. My key question is, I mean, you touched on it, but I wasn't clear if you answered it. If it says must support, can they provide a null flavor, or, well, there is no concept of a null flavor, but a unknown
Well, okay,
value,
so
or?
this is where I'm struggling like crazy with these IGs, is what do you do in those cases? Because I've been told don't make things required, but then my clients are like, but we want to know, and there is an extension, a null flavor extension, which I do use sometimes when the client really wants and they want it to be unknown, but it's supposed to be part of the value set, right? That's the whole idea, is that we're supposed to be putting our unknowns and things like that in the value set, I think. Lloyd's going to tell me I'm totally wrong.
Well, I was going to answer. Yeah, I was going to answer the first question. So if it's just must support, you don't need a null flavor or anything else. You just omit it, because must support says you must be capable of sending it if it exists, but totally fine for it not to. So the common example of that is deceased state. It's okay if they're not deceased, but if they are, then you must be able to send the data and must send it if it exists in your system. Where things get funkier is when the minimum cardinality is one that says you must always send a value.
Well, and that's things like allergies, where they really want to know, the client or whoever's doing this IG really wants to know that they have no known allergies, and they want that stated as a, right, which is different from a null flavor, actually.
So what you're saying is if you say must support and a cardinality of 1,
it's kind of redundant.
Then they have to send something, or no?
Yes.
If the minimum cardinality is 1, then they have to send something, period. It doesn't matter whether it's must support or not. If it's not must support, they could just send a fixed value and say, yeah, we don't really have this in our database. We don't care about it, but it has to be there, so we're going to send this fixed value. Yeah, whatever makes the most sense for their particular space.
Or they could send nothing.
Yeah, so I mean, as an example, if status was min-occurs 1, but not must support, you have to declare a status. If there's an unknown status, they might send that. Otherwise, they might say, well, what's the safest one to send that's going to mess people up the least, because we have no clue, and we'll put that in. So must support is really about your system is actually capable of sending different values and appropriate values. Must support is what must be on the wire.
Well, and the other piece is must support. Must support has the added feature, I'll say, that if your system knows the value, it must send it. Right? And that's where Lloyd was kind of implying a little bit. If you were to put into your profile just min occurs 1, it's very possible somebody's just going to hard code that. And even if they did know the value, sorry, I'm sending the hard coded 1 because you made it easier for me to send the hard coded 1. So must support is actually far more powerful than min occurs of 1. So I would recommend, if you know that sometimes it doesn't happen, do a min occurs of 0 and do a must support. Yes, it's not, automated testing, but it still meets reality better.
Yeah, the problem that I have with that is that lots and lots of clients, lots of our clients want something. So they're not happy with that default state of they don't send anything if they don't have it, because I guess they don't trust them to send something if they do have it unless we force them. Yeah, I had 6 and a half dozen the other.
We're gonna.
Technology can't fix a political problem.
We're gonna.
They're not trusting. They're not trusting.
Yeah.
We're going to talk tomorrow afternoon about good guidelines, including how to say no to clients, because that's often necessary.
Yeah.
So we're going to definitely get into the notion of when should you not use certain cardinalities and must support, et cetera. So is this about something different?
No, it's about this.
Then let's talk about it tomorrow afternoon.
It's directly related to what John said.
Fine. Just because you're Lisa, we'll give you one more.
Call him the Lisa card. John, I appreciate what you said, but I feel like in order to know that it's true, you have to go in the context of an IG and read that repeated, because what you stated as a truth could be completely undone if somebody else writes an IG that says must support means something different than that.
Right, and that's exactly it. Because you said that when they say must support, they have to send it. Is that actually what must support means? Because we just said that it was to be defined elsewhere.
It's defined
Anywhere.
in every IG. And
Right.
I find it
So if it's declared. So we could talk about how to make that more obvious in the templates. That's not a bad thing to do. So it is absolutely not true that, so if it's must support and you are sending an instance, then yeah, must support means that you must send. Where must support typically varies in interpretation is what it means on the receiver side. Does it mean you must store? Does it mean you must print? Does it mean you must be able to return or pass on or include in decision support logic? That's where the variability typically comes, is what does must support mean on the part of a receiver. On the part of a sender, it's essentially always if you got it and the user has, or the recipient has the permissions necessary to see it, then you must send it. So the privacy requirement always trumps, but you can't get around it by saying, well, my privacy policy says nobody can ever see this, therefore I get out of jail free. Either to qualify as, yes, I actually support this, there must be some class of users for which you could send the element and your software actually does send the element.
So is that written down anywhere, that spiel that you just went
I'm
through?
sure I got it in PowerPoint slides somewhere.
No, I mean in the documentation. Right.
Maybe.
This very much gets to what Lisa was speaking of.
Yeah, totally.
That today the definition of must support is it will be defined in the implementation guide.
Right.
That's all that's in there in the core spec on must support is you have to look at your implementation guide. Now, the organizations will start to create a consistent definition for must support. And for example, within IHE, we do have a consistent definition for must support. It is equal to R2, which is also used, and RE that's used here. But like Lloyd is suggesting, those rules are only on sender side. They're not on receiver side. And on receiver side, generally every time you use a must support, you do need to explain for that element what must support means on the receiver side. So you can come up with a sender side, pattern, and it probably could be organizational. I don't know. We could float it up to core. I would certainly like to see the core sender requirement, but that's one reason why must support is really not well. It begs off to the implementation guide defining it.
The other thing to realize is like any other constraint in an IG, if you are inheriting it, so if you're basing yours off US Core, you are inheriting US Core's definition. Okay, so if my IG is dependent on US Core, I've just inherited US Core's must support rules.
Linda Michelson was the one who told me that that's not true.
Linda Michelson is not teaching this course.
What did I tell you? That if you have an IG that inherits from another IG, that the child IG can go and define must support some other way.
It inherits it that you can further define it.
You can further constrain it.
Right. And that's what, for example, QI core does. When they say we take US cores and additionally we, whatever.
So tomorrow afternoon we will be discussing this, Lloyd. I think we will eventually be talking about flavors of must support. That's what I'm hearing.
We'll be talking about a bunch of things. That'll be one.
Standardized flavors of must support.
Yeah, we won't. Let's not overpromise here, Lloyd.
By the way,
Our conversation.
what we forgot to do is go around introducing everybody. So I don't even know everybody's names. Like, I didn't know that was Linda Michelson, but I know now. So I think at the end we need to go around and do an introduction before we finish, just so that we know everybody.
Really? Okay, if you think so.
Yeah, I do think so. Okay. Wow, must support. I didn't think that was going to get so much discussion. Structure, definition, resource. I think Dragon already went over this. It's the definition of a FHIR structure used to define base resources, data types, extensions, everything in FHIR. Describes a structure, set of data element definitions and their associated rules of usage. This is the UML diagram. We won't look at that very closely. These are the important fields, and I think Dragon also went over these earlier. Then the structure definition element. I don't think you did so much on the structure definition element. So element, you have all the different elements that you're going to having in there. So like your questionnaire.code and the different elements, but you can also define things underneath there, like we saw with the with my pictures of the 3 different things. So it is of 8 element definition data type, and the important things in here are path, cardinality, data type. We have definitions, usage notes, and requirements, default or fixed values, the constraints, cardinalities, terminology bindings, mappings, and slicing. So these are the actual names of fields. I won't go too much into those, but we've seen some of them, like the slice name and slicing. A short definition, you can have a short description, you can have a definition, minimum, maximum, the data type of the resource or profile of the element, the fixed value, the pattern, must support, and binding. There are others, these are just the main ones. So I was just gonna go through the US Core patient. I wonder if this will work, me clicking on there.
You'll probably have to drag the browser across.
Oh yeah. So I'm gonna have to stop the PowerPoint, aren't I? It took me there. Yeah. But, okay, so now I can probably move it over. See what happens.
It's on screen, so you're good.
Okay. So is that big enough, or should I?
Make much bigger,
Control
please.
plus?
One more. There we go.
So this is the US Core patient, and it's a, here we have the differential view of the US Core patient. So this shows quite a few things in here. We've got the, I don't know if it has slicing in here, actually. Oh, it's the one thing it's not missing. What was the one that someone said that is a
Prac-
good
practitioner is good for slicing.
practitioner? Okay, we'll look at that after. So we have a couple of extensions. So we have US core race and ethnicity are extensions. They need to be extensions because I think in Europe you can't have them. I learned that on the video yesterday. But you know, we need them in the US. We have a lot of must supports. You can see all their must supports. And if you look at what's called the full view here, you can see that these things aren't must supports necessarily in the original. What else do we have in here? I think that things like name are required, whereas maybe they're not. Name and identifier are required, whereas you know, they got a 1 here, whereas they weren't in the original one. We have a binding to a state, USPS 2-letter alphanumeric codes, and that's an extensible binding. We have a binding up here to administrative gender, which is required. So I'll just quickly look at US core practitioner, and we can just look at an example of slicing. So there we go. So we have an identifier, and that's what someone was asking about, whether you can slice by identifier, and that's exactly what that is. So that's
I have a question.
sure.
In older versions of FHIR, it was much easier to see what you were slicing on. And
You mean in the older versions of the IG publisher, what was rendered?
yes, like you
this
could
one? Are you
see
talking about this one's better, or
the older ones.
Oh, even
You
older
could
ones.
actually see what the slice was. You know what you had discriminated on.
Well, I think. Well, this is what you've discriminated. This is what you've discriminated on right here because it's
By-
identifier and it says slice.
But how do you, so you know, I guess that the system up at the top is telling you what's discriminating on, and then the fixed value next to system is what it's, you know, that must be an NPI.
That's more visible on the build site. That's the current published version, so I think it's
Yeah.
more visible on the current build than
Yeah,
it
and
is
it
here.
may have changed. Like if we looked at I don't know how to get to.
That's okay.
Like-
If it's changed, it's
Th-
better. It's
yeah, things change.
really hard.
Yeah,
What's
it
the
looks
link
better
to-
on build.fire.org.
What's the build.fire.org?
No, not www.
No, I was going to ask that. Fire.org.
Build.fire.org, for those who want to know, is where the consistent updated one. Continuous integration
So am I
builds
doing
are.
something wrong here? Is it CI build somewhere?
No, you got to take all that out. Get rid of US core. Oh,
Go to US core, go to version.
Yeah.
and then-
yeah. Go back to US core, go
My
to
favorite
version,
thing,
and go to the CI build.
Oh yeah. No, that's the best way, isn't it? That is the best way.
Up at the top, way up at the top. Click on the history page link.
I was going to wait, but I guess it's taken a while.
There we go.
So this one. Wow.
Yeah,
How
go
does
to
this work?
go to back to
Profiles.
profiles and that.
Practitioner.
There, that's a better
So
version.
this is how it is now, I guess. Wow, I don't remember seeing that on mine. Identifier all slices content. Oh, maybe they set that as a separate slice. Anyway, so it is slightly different. It's got slice definition in here now, and yeah. But I'd say, like, if it's not clear, maybe you can always mention it to Graham, and he can fix it, wherever Graham is.
Graham stepped out for a bit, so we can make fun of him while he's not here.
Anyway, questions?
Well, I'm having trouble reading that version, but just to clarify, so what that's saying, that slice is saying is that you might, they have to, well, I can't see it, you have to provide, but you.
You
or
do.
you
Yeah,
would
it's
provide,
one
I can't read it
thing
from
is you
here,
have to have
okay.
at least one identifier.
At least one identifier, but one, see, I can't read it there. I was looking at the old version, and it said they would have to have an NPI, but they could have some other type of just wide open
Yeah.
identifier. Okay,
Yeah.
thank you.
So I think that's what this one is.
Yeah, as you can see, the required pattern says at least the following, which is identifier and PI, and then it says anything else. So you can have any other identifier that makes you happy.
Yeah, and it's pattern. It's done by pattern because it's a. Huh. That's interesting because it says fixed value and it's got a.
Yeah, it gets weird.
That's not how.
Slicing is tough, kids.
Yeah, no, but that fixed value on a value set, usually it comes out as a binding required on a code, on a value set. But anyway, I don't know what that is. Any other questions about what we were talking about? Because that's the end of what I'm talking about in terms of profiling.
So I'm just curious, on that same one, it says one-to-many on the slice.
Right.
So that means that slice so you could have more than one NPI.
Yeah, but you have to have one or many.
Because it happens.
A unique body has more than one NPI.
Oh, no, you don't have more than.
A facility can, but not an individual provider, but I believe a facility can.
Well, the NPI is 0 to 1, though.
No, but the identifier.
But you can only have one NPI. You can have more than one identifier, but you can only have one NPI.
Well, it could be a local identifier, like the facility has their own identifier.
Even
Right.
though it's showing it on the
Right.
slice,
Well, this display is weird.
it is weird. I'm having
Although
trouble with it because
the
when
other
you
one
look
is
at the
kind of
full
weird too,
view,
because you're like,
when you look at full view, you get your slice
Right.
in addition to your non-slice.
And, the thing is, when was this published? This was published on the September 2nd, so that's like 7 days ago. Who knows what has changed in the IG publisher since then as well.
Yeah, don't laugh. It changes that often.
and this is why you have to pull the IG publisher into your project.
Right.
Yeah.
Stick with it.
It is important.
Until you get through that.
It is important that when you build it, if you're going to do it that day, update publisher. Things change, things break, things get fixed.
Yeah, and if you can't figure out what's going on and all of a sudden things seem to be broken and they weren't broken before, try updating again.
And-
Because Graham may have fixed it.
And yeah, and if you update it and things break
Right.
in unexpected ways,
Yeah.
that's what chat.fire.org is for.
Yes. And that's part of the problem is you spend a lot of time going, is it me or is it the publisher? And then, because I don't want to write some Zulip thing for them all to go, oh yeah, no, it's not, it's you. But anyway.
Yeah, so Sarah, for MPI, there's a OID for identifies MPI. So how does this work here? Because
no
over
idea.
here it's a system
Isn't this
and
yours,
points
Dragon?
to. It is so. Yeah, it's just not. It doesn't seem correct.
So it's
At
got-
this point, it's
what's
not important. It's just to
No.
show the way the
Yeah.
slice is set up.
Yeah. Oh, in the URI, in the URI.
So that would be the system.
I think so, yeah.
Yes.
Yeah.
Yeah.
Their specific NPI would go on the value.
But the OID that states that it's an
Can,
NPI
can you
goes
put
in URI.
Can you put up the differential for your score? You can actually see what the code system requirement is.
Yeah.
So you see the fixed value for the system is hl7.org.fire. I can't read what SID. USNPI. That's for code system. We'll talk about that tomorrow when we talk about terminology.
Oh, is that a code system?
Yeah.
It's not an OID in
No, it's not. It's a URL. It's been.
It's not a code system, it's a naming system registry, whatever that is.
Oh, stop. Okay. Anyway, we need to move on.
Yeah. Okay, and I'm done. Thank you.